Hi Pre-Calc, this is section 2.6. Okay, let's try number 37. Let's start by factoring this. Needs to be -6. -6 plus 1 is -5. Okay. The bottom one is 4 terms, and 4 terms you're going to need to do factor by grouping on this one, or if it's more difficult than that, you can do that technique you learned in 2.5, which is to factor the polynomial. Right, you do Descartes' rule of signs, the rational zero test, all that. This one actually does grouping. So how you do grouping is you put the first 2 together, the last 2 together. I'm going to take out an x squared from the first 2. You always have to carry down the sign of the third term. Now there's nothing in common here, so I'm just going to say a 1. Now I'm factoring out a negative, which means it has come out from both terms, so it looks like this. Right, because I have the parentheses, so if I distribute the negative back in, I get that. Now you take out the common binomial, which is x minus 2, and then the leftover for that would be x squared minus 1. So once I take out the common factor of x minus 2, the common factor of that, I'm left with x squared minus 1 as the leftovers. And x minus 1 is a difference of perfect squares, so it breaks down further. Okay, so that's what we're going to get. Let me just write that on my other sheet of paper. Just give me 1 second. Now the first thing I checked, and I just sort of do this automatically, was that I didn't have any common factors, because common factors make a whole, and then I would have done all of this off of the reduced form. But there's no common factors here, so this one's good. This one's a good fit for what we need. Alright, so let's go through everything now. So x here cannot be, can't divide by 0, it can't be 2, negative, or positive 1. The x-intercept, if we set the numerator equal to 0, we're going to get that x is -1/2 and 3. Now, you just have one of this binomial and one of this binomial, which means that they're both odd. They're both odd, okay? I don't know what form you guys prefer to see this in, so I'll write it both ways. Customer service here. Right, so these are your x-intercepts. They're both odd. Okay, y-intercept, you got to let everybody be 0. All the x's be 0. I like the original form for this. You could put it over here if that's what you like. Okay, so the only survivors would be the -3 in the numerator and the 2 in the denominator. So it's going to be a -3/2. If I write it as a point, it looks like that. Okay, the VA, that's where all where the denominator is equal to 0, assuming the numerator isn't. So we're going to get 2, -1, and 1. These are going to be your VAs, and as you can see, they're all first degree. They're all first degree, so it's linear. They're odd. My brain just didn't want to figure out what that word was. Okay, they're all odd, and remember, odd for a VA means opposite direction. Odd for an x-intercept means it goes through the x-axis. I just want to keep saying it because at some point it'll register and it won't be seen like so confusing and so many rules. Okay, HA, that's where you look at the degree of the polynomial. So the degree of the numerator is a 2. The degree of the denominator is a 3. So it's a second degree over a third degree. There's more, the exponent is higher in the denominator, which means that it's bottom heavy, so it's going to go to 0. Y is going to go to 0 because it's bottom heavy. And if you caught what I said in the previous example, you can probably tell if it crosses or not, because it is going to cross. But I'll just work out all the steps for people who are trying to figure this out. just be patient with yourself. A lot of having longevity in education is just being willing to, you know, have some grit. If you don't get it the first time, try again. If you don't get it the second time, try again. It's just having a lot of grit when you do something difficult. People that have faith that they will figure it out, you know, have a lot of grit, a lot of gumption, will eventually figure it out. It's just, you know, are you willing to hang in till you figure it out? Because difficult is difficult. Okay, so as you can see here, if I set this equal to 0 and I cross multiply, this equals to 0. So this is going to give me the x values, which is -1/2 and 3. And so it's matching the x-intercepts, and it's the same logic as before. If the HA is on the x-axis, and you already have points on the x-axis, then they're going to have to coexist. If HA is on the x-axis, and you have 2 points on the x-axis, then the function's going to go, you know, they're going to coexist. So it would be yes, you cross HA, and where you cross it is at these 2 points. Okay, gang, let's get down to business here. Let's see what we have. Let me use a different color here. Okay. All right, so we got an x-intercept at -1/2 and at 3. And we said that they're both odd. So this guy's odd, this guy's odd. We have a y-intercept at -1.5 or -3/2. We have a VA, we have lots of VAs. Okay, so we got a VA at -1. That guy is odd. We have a VA at 1. That guy is odd. We have another VA at 2. That guy's also odd. And we have a HA at 0. Alright, so once I put up everything, what goes through my mind is, do I have enough information here to graph it? And what do you think? Do you think we have enough information here to graph? Is there any spot on this graph that you could start at where you're positive you know what it looks like? Okay, and the answer is yes. There is enough information here. We can do this. And the reason we can do this is that I know that these 2 points have to connect. And since this is odd, and I know on the right side I'm below the x-axis, then on the left side of this x-intercept I have to be above it. So it's going to go like this. And then this side has to go like this. And I can see all of it. Let me fix the Leaning Tower of Pisa here. All right, there we go. All right, now I'm just working on this VA. So you have to really squeeze your eyeballs into focus. Don't be staring at this guy. Stare at this guy right here. I'm looking at this guy. On the left side, this is going south. So on the right side of this particular guy, it has to be going north. Okay? Because this guy's odd. Now, this is where it gets a little tricky. This is an approximation. If you notice, I don't have an x-intercept here, so I cannot cross. You can only cross HA where you have a door or an x-intercept, so I can't cross. So I know I can't go through this. So all I can do at some point is bend and come back up. Okay, I know that's confusing, but I will not go through. There's no x-intercept. And the biggest question I get from students in something like this is like, well, how far do I go down? And that's the thing. Until you take calculus, we don't know how far you go down, because we don't know. You would have to figure out where the derivative is equal to 0. That's where it turns. And since this isn't a calculus class, and hopefully you all are going to take calculus. Calculus is a wonderful experience. We don't know how low this is going to go down in this class. So at some point, just turn around. If a student makes it like really high before they turn around, or really low before they turn around, it's full credit. is full credit. You understand that it turns around. That's the expectation in this course, is that you realize you can't cross the HA, so at some point you have to turn around, because it's all you can do. If I had a little mouse in here, that's all it could do. It'd be a wall, wall, wall. All it could do at some point is turn around. Okay, so now we're over here. Now this guy is odd, which means it's going in opposite directions. So just look, make sure you're just looking at this guy. Don't look at the other VAs. So on the left side of this particular VA, I'm going north. And since it's odd, that means that on the right side of this particular VA, I have to go south, because that's what makes things odd. Okay, so here I go. Now this is a little different because I've got a point, and it's odd, which means I have to go through. All right, so this is another question I get from students is, let me just sort of finish it and then come back and talk. You have to come down to the HA when you're done. You have to, over here on the right, it has to be riding the HA. So it's sort of like it bumps through and it then comes back down. It's not going to go to infinity. It has to stay on the HA. That's what the HA is. The graph wants to approach the horizontal asymptote as you go to positive or negative infinity. So a common question I get here is, well, how big is this bump? How high do I go up? Do I make just a tiny little thing or a big thing? Like, they get very confused here. And again, that's calculus. Where this turns around, how high it is when it turns around is calculus. So if these are questions that are interesting to you, that you're going to answer this kind of stuff in calculus. You're going to figure out where the derivative is equal to 0 and what x value that happens. And that's going to tell you what the height is on the graph, okay? Because that x, when you plug it back into the function, will give you the y, which is the height of how high that goes. All right, now let's come over here, and the VA here is negative, is odd, so we're going north on the right, so we're going to go left. On the left side, we're going to go south, and we're going to just ride this like this. And again, there's no x-intercept here, so you can't cross anywhere here. Okay, this is a really cool and interesting graph. I hope you enjoyed that. I'll catch you again. Bye-bye.